Dear students, now we are going to learn the units of length. The standard SI unit of length is meter and it is denoted by the letter M, a small letter M. In 1983, the International Standard of Bureaus for Weights and Measures has redefined the meter in terms of speed of light, according to which 1 meter is considered by the distance traveled by light in one of 29 crore 97 lakh 92,458 of second in air. So that much precise they have defined how 1 meter is, and they have kept it as up to this day as this is the standard measurement for 1 meter. Okay, I hope it is very clear for you. So this is what they were trying to define for each unit. Okay, now we will be moving on to the next topic, that is the sub units of length. Okay, so let us see what are the sub units of length. There are most commonly used four subunits of length: centimeter, millimeter, micron, and nanometer. First one is centimeter. 1 centimeter is 100th part of meter, or we can say 1 centimeter is equal to 1 by 100 of meter, or 10 raised to minus 2 meters. And 1 millimeter is the 1000th part of a meter, or 1 by 1000 meters, or 10 raised to minus 3 meters, or we can say 1 by 10th of a centimeter. Micrometer or micron, it is the 1 millionth part of a meter and it is expressed by the symbol mu, and it is also called micron, and it is 10 raised to minus 6 meters or 10 raised to minus 4 centimeters. Nanometer is the almost smallest part, 1 billionth of the part, and it is 10 raised to minus 10 meters. Now you see multiple units of meters, and the highest multiple unit for meter is kilometer. 1 kilometer is 1000 multiple of meter. That is 1 kilometer is equal to 1000 meters. So now you see the non-metric units of length. The first one you see is the astronomical unit. One astronomical unit is equal to the mean distance between the earth and sun. That means you see distance between the earth and sun, that is equal to 1.496 into 10 raised to 11 meters. And the light year, the distance traveled by the light in 1 year is called a light year, and it is denoted by using the speed of light into 10 raised to into 1 time 1 year, and that is equal to 9.46 into 10 raised to 12 kilometers. And the smallest values of light year is called a light minute and light second. You just knew the values. And another non-metric unit is parsec. This is just you try to understand. 1 parsec is the distance traveled within the semi-major axis of the orbit of Earth, subtend to have an angle of 1 second. Okay. And similarly, smaller units also there to represent the wavelength of light, size and separation of particles, molecules. They are called angstrom as well as Fermi. What is known as angstrom? Angstrom is 10th of the 10th part of a meter. Very small, and it can be 10 raised to 10 into 10 raised to minus 10 meters. And 1 micron is called 10,000 angstrom, and 1 nanometer is 10 angstrom. So it is very short. And you see Fermi also. Fermi is 10 raised to minus 15th part of it, even very short of it. Okay, you see now here and an image that is in the text. You just go through this image, that what it is, and the sizes, bigger and smaller units. Now you see we are going to move to the next topic, unit of mass. The SI unit of mass is kilogram. In 1889, they standardized 1 kilogram was redefined as the cylindrical piece of a platinum iridium alloy kept at the International Bureau of Weights and Measures at Sèvres near Paris. and it can be also redefined as 1 liter of water is equal to at 4 degrees of temperature, it is equal to that of 1 kilogram. Okay. Now subunits of kilogram. The smaller units of kilograms that we commonly use is gram and milligram. 1 gram is 1000 part of kilogram, that is equal to 10 raised to minus 3 grams. 1 milligram, it's 1 millionth part of the kilogram, that is 10 raised to minus 6 of kilogram, or 1 milligram is equal to 10 raised to minus 3 gram. Now, the higher weights of kilogram, what are they? We have two, quintal and metric ton. What is quintal? Quintal is 100 times ahead of kilogram. That is 1 quintal is equal to 100 kilogram. What is metric ton? Metric ton is 1000 times higher than the kilogram. That is equal to 1 metric ton is equal to 1000 kg or 10 quintal. So some non-measurable or non-metric units of mass. That is they are the atomic mass particles and electrons, and they are expressed as atomical mass unit or AMU, or you can say unified mass unit. And now we are going to find out the value of AMU. AMU is the 1/12th mass of one carbon 12 atom. Okay, so there are some max given in it, just you see, but we don't need to study, but we just understand. It is a multiplication of the mass with the standardized number of Avogadro's number, and finally we get 1 AMU is equal to 1.66 into 10 raised to minus 7 kg, 27 kg. Okay, you just keep the value in mind. And here also I have given an image of the smaller and bigger units of mass and their values. Just keep it in mind and we need to study. Okay. Now the next topic is the unit of time. The standard unit of time is second, and 1 solar day is the time taken by the earth to complete one rotation on its axis. Okay, that is what we have to just remember about a day. In 1964, a second was defined in terms of energy in cesium atom as follows. They have redefined this task, and it is given below. Just read it. It is a time interval of 9 crore 90 lakh something that, and it is redefined in order to find how much a second would be. Okay, so it is a standardized version, and that will help you to understand how precise they have trying to redefine the value of each and everything in that is given in us. Now we see the smaller units. There are mainly 4 smaller units we have to study of time. One is millisecond, microsecond, shake, and nanosecond. 1 millisecond is equal to 10 raised to minus 3 second. Microsecond is equal to 10 raised to minus 6 second. Shake is 10 raised to minus 8 second. Nanosecond is 10 raised to 9. So you see it is reduced and it is smaller units. Now see bigger units. These all are the very familiar things you know, bigger units. First one you will see the minute. What is minute? 1 minute is a duration of 60 seconds. That is very commonly we know. And 1 hour is 60 minutes. That means 60 minutes, 60 into 60 is equal to 300 seconds. Oh, we know. That's very casual we know. And the time, the days we know. It is a day of one rotation in its own axis. And it is divided into 24 hours. Therefore 24 into 60 is equal to 1440 minutes. That is equal to 86,400 seconds. Okay. So you see lunar month. That is also the thing that what followed by Indians. Westerns follow the Gregorian calendar. And based on that we have 1 month is 29.5 days. And the period of 12 lunar months is equal to 354 or to 337 days. It is varies. Now month that is followed by Western is Gregorian calendar, and they have certain months have 31 days and certain months have 30 days, and February has 28 days we know, and in a leap year it comes 29, and in a 12 months time we have 365 days. That is a standard version, right? So here just now they defined as it is completed by the earth around rotating revoluting around the sun. So it is actually they calculated as nearly 365 days. It is not actually 365 days, it's nearly. So it varies. So 1 year is equal to 365 days and it is equal to 3.1536 into 10 raised to 7 seconds they are calculating. One leap year means that in every 4 years, the February comes with an extra day, that is 29, and that is called a leap year. Okay, and now we are seeing a decade. A decade is what? Nothing but a 10 years. When you take 10 years together, it is called a decade. And centuries, and when we take 100 years together, that is called a decade. You see, they are just we are giving just how many seconds it would be. Decade is 3.536 10 raised to 8 seconds, and also a century is 3.16 into 10 raised to 9 seconds. That is just like math, but we need to understand what is decade and century. Okay, and now what is millennium? A millennium is of 1,000 years. That is, 1 millennium is nearly 1,000 years together. And you see, I have given the image of nearly bigger units and values. You just look into it, and now finally we have reached the derived units of physical quantities. So this part you have to see it is in your textbook. You carefully read it and try to study their abbreviations and symbols as well as the derived units. Okay, so it is very important that in your further classes you will need this one. So you need to study thoroughly their abbreviations as well as their derived units. Okay, and finally we have reached the guidelines for writing units. There are certain things you need to do when you write units. The first one is that if it is not a name of a scientist, if a unit is not named after named after a scientist, you have to write them in smaller letters. And if it is named after a scientist, you have to write the letter first one in capital letters. Okay, you see that I have given the examples. If it is a name of Newton, it's N, and if it is a name of Joule, it's N. Finally, and if you are to write it the unit in full name, whether it is a scientist name or not not other name, it should be written in smaller letters, not in capital letters. If you want to write the full name, you should write it in the smaller name, small letters. Okay, and a compound unit, if two units are formed by multiplications, you write it, then you should give them a gap. You don't write them together, or you should either you put a dot or you put a multiplication emblem or you give a space if two compounds are formed by multiplication. Okay, and finally, if a negative power is used for a compound, and if two units are there and you want to give one negative form, then how it is should be, the negative amounts are comes by dividing them. You see, when if you see want to find the unit of velocity, meter divided by second, how do we write? A meter second raised to minus 1, since second comes underneath. The same with the second one also, joule second per minus 1. Finally, the sixth one you see, unit is its short form is never written in plural forms. Okay, you cannot write it in the plural form. 10 meters we can say. If you write in 10 members, then it will go different meaning. That means it will be milliseconds. So you should not write like that. And also to avoid the power of 10, you should see that it cannot be written like a very big letters combining together. It should be written in a proper way. You see, if you want a kilo megawatt, you cannot write like that. Actually it should be gigawatt. And you see, and it should be when you use prefix in the symbols, it should be the unit of symbol of should be in written with a new symbol. Okay, you see, when the prefix is used with the symbol of unit, the prefix and the symbol combined becomes a new symbol. You see, kilometer cube is actually 10 raised to 3 into meter the whole raised to cube. That means the value changes there. Okay, 10 raised to 9 meter cube, and it doesn't mean that 10 raised to 3 meter cube. I hope it is clear for you for this today, and we will be trying to learn furthermore through exercises. Okay, thank you, students.